Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like algebra, inequalities, time speed distance, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to start a new topic, sequences and series. So let us start with today's video. In sequences and series topic, first we'd be seeing what is a progression, which is defined as a series of numbers arranged in a predictable pattern. A progression can be generally classified into three different types, such as arithmetic progression AP, geometric progression GP, and harmonic progression HP. We would be seeing these three progressions individually and how we can find the nth term and the sum of n terms of these three progressions. Post that, we'd be seeing some series following some specific sequence. One of that series is AGP series, which is a combination of arithmetic and geometric progression series. We'd be also seeing some more series following some specific pattern and how we can find the sum of the terms of those series by following some specific approach. So let us begin with arithmetic progression. An arithmetic progression is defined as a series in which the difference between any two consecutive terms in the series is same. For example, let us consider this series 5, 10, 15, 20, 25, 30, and so on. So in this series, if I take any two consecutive terms, say 10 and 15, in that case, the difference between these two consecutive terms, that is 15 minus 10, is 5. In a similar way, if I consider these two terms, the difference is also 5. So in this series, if we take any two consecutive terms, in that case, we'd be getting the same difference. So that's why this series can be termed as a arithmetic progression series. Now, if we generalize this, we can write the terms to be A plus D, A plus 2D, A plus 3D, and so on, where A is called as the first term and this D is called as the common difference. So for this series, A is the first term, A plus D is the second term, A plus 2D is the third term, A plus 3D is the fourth term, and so on. So in a similar way, if we want to write the nth term, that is Tn, in that case, this can be written as A plus n minus 1 into D. As in the second term, we are getting A plus 1 into D. In the third term, we are getting A plus 2 into D. In the fourth term, we are getting A plus 3 into D. So in the nth term, we'd be getting A plus n minus 1 into D. So the nth term for an AP series is given by A plus n minus 1 into D. Also, the sum of the nth term of an AP series Sn is given by n by 2, 2a plus n minus 1 into D, where n is the number of terms till which we want to find the sum, A is the first term, and D is the common difference. This sum of n terms can also be written as n by 2 A plus n minus 1 into D. So now this can be written as n by 2 A, which is the first term, so I'm writing it as T1, and A plus n minus 1 into D is the nth term, which I'm writing it as Tn. So Sn, that is the sum of n terms of an AP, can also be written as n times of T1 plus Tn upon 2. That is n times the average of the first term and the last term. Now when the number of terms in an AP series is odd, in that case, the average of the first term and the last term is given by the middle term. Let us consider the same AP series and let us consider the number of terms in this series to be 5. So the series would be 5, 10, 15, 20 and 25. So here 5 would be the first term, which would be T1, and 25 would be the nth term or the last term, which is Tn. So the average of T1 and Tn in this case would be simply 5 plus 25 by 2, which is 30 by 2, that is 15. And 15 is nothing but the third term, that is the middle term. So when the number of terms in an AP series is odd, in that case, the sum of n terms of the series can also be written as n times the middle term. So for this series, the sum of the 5 terms can be written directly as n, that is 5 into the middle term, which is 15. So that is 75, which we can also verify by simply adding these 5 numbers. And we can see 5 plus 10 plus 15 plus 20 plus 25 is also 75. So when the number of terms in an AP series is odd, in that case, the sum of n terms can be written directly as n times the middle term. So any series in which the difference of any two consecutive numbers is same, that series can be termed as an arithmetic progression series. And the nth term of such series is given by a plus n minus 1 into d, where a is the first term and d is the common difference. Also, the sum of n terms of such kind of AP series is given by n by 2 into 2a plus n minus 1 into d, which can also be written as n times the average of the first and the last term. And if the number of terms in the AP series is odd, in that case, the sum can also be written as n times the middle term. Now, let us see this question based on the AP series. So we have been given a series 2, 5, 8, 11, 14, and so on. And we need to find the 50th term in this series, the sum of the first 100 terms in this series, and the difference between the 42nd and 45th term in this series. First, if we notice, the difference between any two consecutive term in this series is same, which is 3. Because 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, and so on. So this series is an AP series, where the first term A is 2, and the common difference D is 5 minus 2, that is 3. So the 50th term of this series can be found out by writing it as T50, which would be A plus 50 minus 1 into D, and the value of A is 2 and the value of D is 3. So this would be 2 plus 49 times of 3, which would be giving us the 50th term as 149. So the 50th term of this series is 149. The sum of the first 100 terms of this AP series can be found simply by using the formula, which would be S100 n by 2, that is 100 by 2, times of 2 into the first term, that is 2 into 2, plus n minus 1 into d, so that would be 100 minus 1, that is 99, times of d, that is 3. So if we simplify this, the sum of the first 100 terms would be 15050. Now for the third part, where we need to find the difference between the 42nd and 45th term in the series, what we can do is we can find the 42nd term of this series and we can find the 45th term of this series and we can take the difference. But that would be a little bit time consuming. So instead of that, let us use a shorter way to find the difference between these two terms. If we write in a generic way, the 42nd term can be written as A plus 41d, and the 45th term can be written as A plus 44d, which we can write simply by using the nth term formula. So the difference between these two terms can be written as a plus 44d minus a plus 41d, which is nothing but 3d. That is, 3 times the common difference will give us the difference between the 42nd and 45th term for this series. And we know the value of the common difference is 3, so 3d would be simply 9. So instead of finding the 42nd term and 45th term and then to take the difference, we can directly apply this approach. Now let us see one more question on the AP series. The sum of the first 5 terms of an AP series is equal to the sum of the first 7 terms of the same AP series. We need to find the sum of the first 12 terms of this AP. So we have been given the sum of the first 5 terms of this AP is equal to the sum of the first 7 terms of the same AP series. So if we use the formulas directly, in that case, the sum of the first 5 terms of this AP series can be written as 5 by 2 into 2a plus 5 minus 1 into d, that is 4d. In a similar way, sum of the first 7 terms of this series can be written as 7 by 2 into 2a plus 7 minus 1 into d, that is 60, where a is the first term and d is the common difference. If we simplify this, we'd be getting 2a plus 11d equal to 0. Now, the sum of the first 12 terms of this AP can be written as n by 2, that is 12 by 2 times of 2a plus 12 minus 1 into d, that is 11d. And we know 2a plus 11d is equal to 0. So this would be 6 times of 0, which would be 0. So the sum of the first 12 terms of this AP series is 0. Now let us try to see one more approach to solve the same sum. But before that, let us try to learn one more shortcut here. We know generally for an AP series, we denote the first term by a and the common difference by d. So suppose for an AP series, if I want to write the 8th term, in that case, this would be a plus 7d. In a similar way, if I want to write the 7th term, in that case, this would be a plus 60. So the sum of the 7th term and the 8th term would be simply 2a plus 13d. In a similar way, if we want to find the sum of the 6th term and the 9th term of the same series, this would be a plus 5d plus a plus 8d. And this would be also 2a plus 13d. In a similar way, if we take the sum of the 4th term and the 11th term, in that case, this would be a plus 3d plus a plus 10d. And this will also give us 2a plus 13d. So the sum of 7th term and 8th term is 2a plus 13d. The sum of 6th term and 9th term is also 2a plus 13d. The sum of 4th term and 11th term is also 2a plus 13d, and so on. So what we can notice here is that the summation of 2 terms of this AP series can be replaced by the other 2 terms of this AP series where this summation is same. For example, in this case, 7 plus 8 is 15, and this is giving us 2a plus 13d. So this can be replaced by 6 plus 9, whose summation is also 15, and this is also giving us 2a plus 13d. In a similar way, this can also be replaced by T4 plus T11, as the summation of 4 plus 11 is 15, and this is also giving us 2a plus 13d, and so on. So this T7 plus T8 or T6 plus T9 or T4 plus T11 can also be written as T3 plus T12, as here also the summation would be 15. Now let us apply this approach in solving this sum. So here we have been given as the sum of the 5 terms is equal to the sum of the 7 terms. So the sum of the first 5 terms can be written as t1 plus t2 plus t3 plus t4 till t5. And the sum of the first 7 terms can be written as t1 plus t2 plus t3 till t7. So from here we can say that the sum of the 6th term and the 7th term would be 0. Now, to find the sum of the first 12 term of this AP, we can write it to be as S12 as 12 times the average of the first term and the 12th term. Since T6 plus T7 is 0 and the summation of 6 plus 7 is 13, so we can say that T1 plus T12 will also be 0, as 1 plus 12 will also give us 13. So the sum of the first 12 terms of this AP series would be 12 into 0 by 2, that is 0. So this would be 0. So by knowing this shortcut, we can solve this question very easily. So that's why I would suggest you all to remember such kind of shortcuts, as it would save us a lot of time. So the sum of the first 12 terms of this AP series is 0. So that's it for today's video, in which we have seen what is an arithmetic progression series and how we can find the nth term and sum of n terms of such kind of series. And in the upcoming videos, we'd be seeing what is a geometric progression series, harmonic progression series, and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.